So, hello and welcome to just a quick video on Yellow Man physics, and I want to just quickly talk with an introduction to resultant force. If you're watching this video, you're probably doing GCSE science of some description, and if it's a physics paper, particularly if it's AQA paper 2, or I should say AQA combined science, which has fancy names now, like trilogy and synergy, which is very exciting, or if you're just taking the straight physics paper. Both of these, on paper 2, you are going to get questions about resultant force. Forces are one of the biggest topics going in the science syllabus. Okay, so I guess the first question that I should look at is, why do physicists bother about resultant force? So why bother? Well, the thing about resultant force is it tells us what's going to happen. So for example, if we've got Yellow Man here and he experiences a force this way and a force this way, the resultant force is going to tell me what ultimately is going to happen. Okay? What do I mean by that? Well, if we said that this way was 500 newtons, remember Newton is the unit of force, and the force this way was 100 newtons. Then by looking at these two numbers and the fact that they're going in opposite directions, this is the same as Yellow Man getting stretched this way by 500 and this way by only 100. Now, just putting back gently, if you look at these two numbers, the bigger side is going to win. The 500 is going to win. And the resultant force is how much it wins by. Alright? So if we look at these two numbers, 500 is the biggest number. The resultant force in this case is equal to 400 newtons. Now this only tells me to the size. If I want to know what's going to happen, I need to know both the size and where he's going to go, the direction, to the right. And that's gone off the bottom of the screen, but we'll just do that. So I feel like we need a really quick interlude, because I can feel physics teachers all over the world spinning in their grave because of what I've said about just casually throwing in this information. So this brief interlude, I don't know, 20 seconds or something. Bear with me a second. I know you're here for resultant force, but I feel I must quickly tell you that force is a vector. And a vector has size and direction. It's a quantity that has both size and direction. So my answer of 400 newtons to the right, this is the size and this is the direction. It tells us how big it is and where it goes. Okay, so let's do another quick couple of examples. Get Yellow Man, stick in there. If I exert a force on Yellow Man of 50 newtons upwards, size, direction shown by the arrow, and 10 newtons downwards, what is the resultant force on Yellow Man? Remember, your answer needs both a size and a direction. Have a think. And the resultant force in this case is equal to 50, take away 10, 40 newtons. Always remember the unit, and the direction is going to be, well, the top one wins, so it goes upwards. Let's do another one, just quickly. Okay, another quick example. Yellow Man, like that, force that way, 1000 newtons, force this way, 200 newtons. What is the resultant force in this case? Well, again, have a think. So 1000 newton wins, 200 away from 1000 gives me 800 newtons, and the direction that wins is that, so I could actually just, I'm going to go to the right. Now so far I've only been giving you examples in one dimension, so I've either been going across or up, but actually we can change the situation slightly, so don't be put off if you see this, but sometimes you'll get questions where there are forces acting both across ways and up ways, and let's just go with a happy example to start with. 50 newtons down, 50 newtons up. Now when you're trying to solve a problem like this, you take each direction separately. I can't spell separately, so I'm going to say on its own. What I mean by that is, let's go uppy downy, it's 50 newtons up, 50 newtons down. So in the uppy downy direction, 0 newtons. In the across direction, it's still 800 newtons to the right that wins. So overall, the up-down direction doesn't matter, the 0 doesn't affect it, the answer is still 800 newtons to the right. This is my answer. Okay, so what I want you to do now is pause the video and have a quick go at these 4 questions on the screen, and then I'll go through each one just to quickly give you the answer. Off you go. If you're still listening, you haven't paused the video, or you've paused it, now you've unpaused it, I don't know. Anyway, let's go through the answer. So for this one, got 200 newtons that way, 200 newtons that way. The resultant force in this case, and it's not all going to fit, so I'm just going to say RF, stand for resultant force, is equal to 0 newtons. Now the weird thing here is the direction doesn't really matter, because overall the answer is 0. So the examiner won't probably do this to you, but I could say 0 newtons to the right or something like that. It really doesn't matter, because overall nothing is happening in this picture, it's staying as it is, and we'll talk more about that another time. For this one, 40 newtons that way, 50 newtons that way. The 50 wins by 10 newtons, so the answer is the resultant force is 10 newtons, and I'm just going to do an arrow to represent to the right. Like this one here. Let's take each direction separately, the uppy downy, the acrossy. So uppy downy, 800s cancel, so in that direction it's 0 newtons, don't care about it anymore. Acrosswise, it's 1000 this way, only 10 going that way, so the resultant force in this case is 990 newtons to the right. Last but not least, okay, so acrossy ways, 10 and 10, so acrossy doesn't matter either, that's 0. Up and down, 60 and 60, so again overall the resultant force in this case is 0 newtons. Okay, now there is one slightly more complicated example which is really pushing up into the higher end of the grades that I'm going to show you. So in this last example we've done before this, resultant force, we've looked where the resultant force is that way, and the resultant force might be up or down, crossways. But what about situations where the resultant force happens both ways? And what do I mean? So, yellow man here, 100 newtons up, 500 newtons to the right, 50 newtons down, and let's say 1000 newtons to the left. Now, none of these forces balance out or cancel out, so we have to take each direction individually and work it out. So let's go uppy downy to start with. In the uppy downy, the 100 wins, and it wins by 50 newtons. So I say that in the upward direction the resultant force is 50 newtons. In the acrossy direction, the 1000 Newton wins, and it wins by 500. So what we end up with is a resultant force in the acrossy direction is 500 newtons to the left. And so actually what we can do is we can redraw this yellow man image here, and we can say that, I'll just do a quick little yellow man, that actually this situation is the same as 50 newtons up and 500 newtons, which was that direction, 500 newtons to the left. Let's get rid of that. So these two pictures, oh sorry yellow man, these two pictures have the same information on them. It's telling me that overall in the uppy downy direction 50 newtons is winning, or the 100 newtons is winning by 50 newtons. In the across direction, this one's winning by 500 newtons. Now combining these I'll talk about in another video. That's it. Have a nice evening, folks.